Okay. So there can be two things that we can do right now. Chalo dekhte hain. We'll go with the standard thing first, and then we'll move to Cauchy equation. So now the another case, like we were discussing particular integrals in the lecture previous and then before, like 2 days back we were discussing what you can say, but finding the particular integral. So we found the particular integral for the case where we had an exponential on the right hand side. Today we are going to do this the same, like for example, if my differential equation is given as d square plus ad plus b, and in you can say that there is some you can say that there's some, why should I write it as a and b? I should write it as, let's say, okay. And on the right hand side, if you have some f of x, and if f of x is given by some cos ax oblique sin ax, or I can write cos ax plus b, comma sin ax plus b. So if I have the second order linear differential equation of non-homogeneous kind, and on the right hand side, if I have trigonometric functions, particularly sine and cosines, I'm not writing secant, tangent. So what we'll do for those solutions, we'll see later on that we are going to do something called as method of variation of parameters for those things. Okay, but right now, if these are the cases, then how to go about it? So let me write it for the most general case. So general case, if I'm writing that my linear differential operator when operated on y gives me either sine ax plus b oblique cosine ax plus b, and this linear differential operator can be written, like it can be obviously written as some function of d. Then how to find the particular integral? The particular integral in that case will be 1 upon fd. I'm writing sine ax plus b, okay, or like whatever be the case. Let's say, for example, if or cos ax plus b. Then this particular integral, what all you need to do is you just need to replace your d square by minus a square. So you will say that here there is only d. No, whatever is d square, write it as minus a square. Okay. And if d is there, you have to somehow make it in form of d square. Like you have to multiply, divide, whatever you want to do, but you have to convert everything in form of d square. Okay. So your particular integral will become 1 upon f of minus a square sine ax plus b or cos ax plus b. For both of the cases, this will be a particular integral provided f of minus a square is non-zero. We'll do questions, don't worry about it, but I'll try to understand. Karna kya hai? Instead of, like, this is what I'm telling, but otherwise I can solve this entire thing. But overall understand that if your a has, if your d's, if there is like this function, if you expand, this function would have, like, let's say this is only the term. So d square plus ad plus b is there. So instead of d square, you have to write minus a square. Now what about this d? Then you have to somehow rationalize and try to make it in form of d square, and only then you can replace instead of d square your minus a square. This is only true if your f of minus a square is non-zero. What if f of minus a square is equal to 0? What if f of minus a square is equal to 0? There are two cases. Either you do this particular integral by simply doing it 1 upon f of d and write e की power iota ax plus b real part for complex, oblique an imaginary part for sine ax plus b. That is, if your f of minus a square is coming out to be non-zero, is equal to 0, even this term, this thing you can do for the above cases also. But above cases, it is quite convenient that only for d square you have to replace minus k square. If you're stuck here, what you can do, we can find particular integral by finding the real part of 1 upon f of d e की power iota ax plus b for the cos ax plus b, and do 1 upon f d e की power iota ax plus b, find an imaginary equivalent, and you will find a particular integral corresponding to the right hand side if it had been sine ax plus b. And what all you need to do, you have to just follow the approach which you had in the exponential case. You just have to follow the approach, the one you had for the exponential case. Is that clear or not clear?
Yes.
Or
Yes.
अगर ऐसे नहीं समझ में आता, then if f of minus a square is equal to 0, all you need to do is multiply with x, you can write cos ax plus b or sin ax plus b. Take the derivative of the function and place minus a square. If f dash minus a square is non-zero. Or if it so happens that your f dash minus a square is equal to 0, then what to do? Multiply again by x. So this will be like x square cos ax plus b oblique sin ax plus b. These are all particular integrals that I'm writing. These are all particular integrals that I'm writing right now. Okay, divided by f double dash minus a square. So if your f dash a square minus a square is 0 and your f double dash minus a square is non-zero, then you can do this. That is, if your function is becoming 0 at minus a square, and it is not only a simple 0, rather it is a repeated 0 of order 2, then what you have to do, this is how you're going to write, and so on and so forth. Okay, so on and so forth. Is that clear or not?
Clear, sir.
Okay, so this is quite easy. Like if you've forgotten, then things are difficult for you, but overall this is quite easy. So let us take an example again from GATE exam. And these are all from mathematics. Okay, physics people, the questions are very easy. They're very easy. But what I want to do is, like, if you can achieve this level, then physics questions would be very easy for you. So this is why I'm doing all these questions, the difficult ones for you. Question says that all the real solutions of the differential equation given by y double dash plus ay dash, sorry, 2ay dash plus by is equal to cosine of x, where a and b are constants. Where a and b are constants, are periodic if. So what does it say? It says that the real solution of y double dash plus 2ay dash plus by equal to cosine x. This is periodic if option number 8 is given, a is equal to 1 and b is equal to 0. Option number b is a equal to 0 and b is equal to 1. Option number c is, I think, a equals to 1 and b is not equal to 0. And option number d is a equal to 0 and b is not equal to. So these are the options one need to find. So it says that all the real solutions of y double dash plus 2ay dash plus by is equal to cosine x are periodic. So what does it mean by periodic? Means any case your function should be some superposition of sines and cosines. So if that is the case, then your function would be periodic. Okay. But what you see is, the first thing that what comes to mind is, first let us find the complementary function, because total solution would comprise of complementary function also, no? So let us first concentrate on finding the complementary function. So complementary function, see, if del is greater than 0, if del is greater than 0, then y, the complementary function y, would be some linear combination of exponentials. Is that clear? It will be linear combination of exponential, and we know that e ki power x, or you can write e ki power minus x, or you can write e ki power kx or e ki power minus kx or whatsoever. These are not periodic functions. These are non-periodic function. So this cannot be the case. So del cannot be greater than 0. If del is equal to 0 also, then also the solution will be of the form C1 plus C2x, and then there would be some exponential, and then there would be some constant and again x. So clearly this is also non-periodic. Okay, is that clear or not clear? देखो, total solution में क्या आएगा? The total solution, I'm writing here, the total solution would comprise of complementary function plus particular integral. तो पहले तो एक बार let us first think about complementary function. तो complementary function is easy to find ना. तो complementary function में क्या करोगे? Y double dash plus 2y dash plus by equal to 0. Right? This is the homogeneous equivalent to this differential equation, isn't it? So the corresponding homogeneous part for this differential equation would be ideally solving this, isn't it? Now, if this differential equation, if I say that if del is greater than 0, then obviously this will be some linear combination of exponential, isn't it? The complementary function would be some linear combination of exponentials. It is not going to serve our purpose, isn't it? Because exponentials cannot be periodic. Are you getting my point? Like exponentials, we've drawn the graph, no? So exponential, where do you see it? One thing is very clear: monotonicity and periodicity cannot go hand in hand. Write it somewhere. Monotonicity and periodicity cannot go in hand in hand. What does it mean? That if your function is monotonic, then it can never be periodic. Because for a function to be periodic, function's derivative should change sign. So देखो ना, if function is entirely increasing, how will it be periodic? Why will it returns at some point to attain the value it had attained previously? Okay, so in order to attain a previous value, so for continuous functions I'm writing, obviously, like for continuous function, this is the case. So for continuous functions, monotonicity and periodicity cannot go in hand in hand. So if a function is monotonic, it cannot be periodic. It cannot be periodic. Is that clear? So exponential is a monotonic function. So it is completely increasing. It is increasing means it will not attain any value more. It will not attain any value more than once. So basically, it is a one-one function. Periodic function के लिए you have to be a function which is many to one. One-one मतलब एक value एक ही बार attain कर रहे हैं, then it's not attaining. So how come it is a periodic function? For example, sin x, pi by 2 पे 1 है, 3 pi by 2 पे -1, 5 pi by 2 again 1. So it has to be somehow non-monotonic, right? मतलब are you getting my point or not? मतलब 1-1 तो नहीं हो सकता ना. So exponentials are 1-1 function. So it cannot be periodic. And similarly, the second case, it will also not be periodic. So del cannot be equal to 0 and del cannot be greater than 0. Is that clear to you, Alpna, Bharat, Rajit, Saloni? Is that clear?
Yes, sir.
Yes, sir.
What does it mean? It means that your del must be greater than 0. Del must be less than 0, sorry. Your del has to be less than 0. Further, not only that, if del is less than 0, then there would be some accompanying term here, right? Some accompanying term here, and then there would be some terms in cosines and sines. Okay, so if del is less than 0, so first thing, let us first find the roots of it. So if del is less than 0, then root will be minus a plus root over a square minus 4b, and then there would be some, this is negative, I think, because if del is less than 0, then this is negative. So I'll write I will write m1 as minus a comma root over b square minus a, and m2 as minus a minus root over b square minus a. Is that clear or not? यही आएगा, कर लो इसको. If you want to find the roots, you can find it on your own. It will be minus a plus iota root over b square minus a. Is that clear or not clear? यहाँ तक समझ में आया? So the solution will be of the type e की power minus a by 2x, and then there will be some constant c1, and then there must be this beta written all over. So I'll write root over b square minus ax plus c2 sine root over. ये clear है या नहीं है? Is that clear to you or not clear?
b square minus
देखो, बी स्क्वायर नहीं, ए स्क्वायर माइनस 4b, है ना? b माइनस ए स्क्वायर, b माइनस ए स्क्वायर. Is that clear now? अभी तो कोई गलती नहीं हो रही? So the roots will be like minus 2a plus minus root over 4a square minus 4b divided by 2. And I've already written that if del is less than 0, it implies a square would be less than b. So what I'll do, I'll simply take a common out from here. So b minus a square minus 1 would be taken common out. And I think this is clear. Is that clear or not? कहाँ चले गए सारे बच्चे? Is that clear or not? Okay.
Yes, sir.
Okay. So now it says that it should be periodic. The first thing that it says that it should be periodic. So when it will be periodic? It will be periodic if we get rid of this term. Because if this term is attached, it cannot remain periodic. Is that clear? So for function to be periodic, your a must be equal to 0. Because if a survives, then this exponential term will be attached. No doubt it will have some oscillatory pattern. That is, I'm not denying that. Because this is some sines and cosine, this will be some exponential. So no doubt there would be some, if I write it in sine form, this is fine. But your like this term would make it like yearly distances will not be constant. Because see, periodicity means it should repeat itself. So now if this is playing, so your as you go all along, as x tends to infinity, your amplitude will start decreasing. Like it will become very small. So obviously this will not be a periodic pattern. No doubt it is an oscillatory pattern. I'm not saying that it is not an oscillatory pattern. Indeed it is, but it is not a periodic pattern. So if e to power minus a by 2 is attached with this term, it will not let it remain periodic. And what is periodic? A function is said to be periodic if f of x plus t is equal to f of x, and for all x belongs to domain of function. For example, if I say sin x plus 2 pi is sin x, sin x plus 4 pi is sin x. But here it will not be the case. Because if you write x plus 2 pi, because exponential is a 1 function, so x plus 2 pi will be a different value altogether. However, you can control this term. You can write it in terms of sines and cosine. Okay, you इस पूरे को इकट्ठा करके इसको डिवाइड कर दो रूट ओवर c1 स्क्वायर प्लस c2 स्क्वायर. ये जानते हो ना, बचपन से पढ़ा होगा. अगर ऐसा कुछ दे रखा है a cos x प्लस b sin x, तो क्या करो, रूट ओवर a स्क्वायर प्लस b स्क्वायर से डिवाइड कर दो एंड मल्टीप्लाई कर दो. ठीक है. और इसको लिख दो cos अल्फा या sin अल्फा, इसको लिख दो cos अल्फा. चाहो तो उल्टा भी कर सकते हो. सो ओवरऑल यू कैन राइट इट एज रूट ओवर a स्क्वायर प्लस b स्क्वायर sin ऑफ x प्लस अल्फा. So this term can be in compact form, or either you can write in cos x minus alpha. Also, I'm not saying you cannot do so. Like you can write as cos alpha here and sin alpha here as well. So overall, you can reduce this term into some sine or cosine. But what about this term? This is not a one. This is a 1 function. So if you replace x plus 2 pi here, this will become a different value altogether because exponential is a 1 function. So this you can control. Like you can say that this particular term will become periodic, but this will never be periodic. So overall, this will not let it remain periodic function. So in order that function remains periodic, your a must be equal to 0. Is that clear or not? So पहले तो देखो ऑप्शन में कहा a equal to 0 दे रखा है. There were options. So a equal to 0 भूल जाओ, इसको भूल जाओ. Is that clear or not clear?
Clear भैया.
Okay. अब देखो व्हाट अबाउट बी. सो ये हो गया कॉम्प्लीमेंट्री फंक्शन की बात. अभी तक बी पे यू डोंट हैव एनीथिंग टू से. अभी तक बी के लिए यू आर राइटिंग बी बिलोंग्स टू आर अभी तक, बिकॉज यू डोंट नो एनीथिंग अबाउट बी टिल नाउ. बी कैन बी एनी रियल थिंग. Is that clear? Or you can write that your like b can be any real thing. Yes, b can be any real thing. Okay, till now b can be any real thing. Now let us see what would be b in general. What would be b? या फिर और कुछ तरीका हो सकता है क्या बी को पता करने का? हाँ, एक तरीका हो सकता है. यस यस यस. रियल नहीं, इनफैक्ट यू विल फाइंड दैट बी इज पॉजिटिव. देखो यहां तक फॉर एग्जांपल कॉम्प्लीमेंट्री फंक्शन तक व्हाट कैन बी असर्टेड. सो व्हाट कैन बी असर्टेड और व्हाट कैन बी आर्ग्यूड कि योर डिफरेंशियल इक्वेशन वाज डी स्क्वायर माइनस ए एम प्लस बी, and we wanted to see that the function is periodic. So we wanted to first see whether your complementary function was periodic, and we ended up saying that your discriminant must be less than 0. And if a discriminant must be less than 0, then there will be two roots, alpha plus beta and alpha minus beta. And obviously alpha square plus beta square would then be equals to b. So all I can say that your b must be greater than 0. Okay, b must be greater than 0. So this is what you can derive the most from your complementary function. That is from the understanding of complementary function, that the complementary function would become a periodic function only if a is equal to 0 and b has to be greater than 0. Okay, yeah. But what we are told, what we want to find, we want to find all the real solutions. So it implies that we have to also see about the periodicity of yp. So at least our much of our work has been done. We now have an idea that this term, like the complementary function, can only remain a periodic function, if a is equal to 0 and b is greater than 0, or you can write your del must be less than 0. Okay, is that clear? यहाँ तक clear है? Now, what about periodic? What about complementary function? Or what about particular integral? So now particular integral would be what? Particular integral would be 1 upon f of d. Question. F of d, and here it is written cos of x. Right? This is how it is. Now, what is particular integral? Particular integral is just writing d square. Instead of d square, you have to write minus 1. So instead of d square, I will write minus 1. So your d square plus ad plus b, and here I have to write, instead of d square, I have to replace minus. Is that clear? Is that clear or not? Please let me know. Is that clear or not?
Sir,
Okay.
sir -1 क्यों?
देखो, instead of d square, you had to replace minus of a square, where your a square was term attached to your x.
Okay.
So if you replace d square by minus 1, this will be it. So now your particular function would remain as 1 upon b minus 1, clear, plus ad. मैं कुछ गलत तो नहीं कर रहा हूँ, चेक करो. अच्छा, a is 0, so a is 0, so I'll write a is 0, so this will not survive, this will not survive. Okay, because since a is 0, ये तो clear है. Because अगर a 0 नहीं हुआ, then overall your complementary function would not remain to be periodic. So for we are finding that our particular integral must be periodic. So if it is periodic, one needs to understand that we cannot take a equal to non-zero, because if a is non-zero, certainly there may be something here, like something here is fine, that I can somehow multiply d above and below, and I can rationalize and I can find. But overall understand that here it will be a problem. So we have come to a conclusion that at least complementary function will be periodic only if a is equal to 0. So a must be equal to 0. That is quite clear in our head right now. So if a is 0, then this will remain as particular integral. Now, what if your f of d square when replaced by minus 1 becomes 0? If it becomes 0, then the complementary function would be found by multiplying x and then writing this. And if it happens this way, then this is not a periodic function. Are you getting my point? If in any way, if I replace f of d square, if I replace d square by minus a, and if my f of d square when replaced by minus a becomes 0, when a is equal to 0, then the particular integral is given by this expression, x cosine x upon f dash minus 1. And this will be a non-periodic function. Again, understand my point. A function is said to be periodic if f of x plus t is equal to f of x. Now here what will happen? This will be periodic for x equal to 2 pi, but this is x plus 2 pi then. So it will not let it remain periodic anyway. Or if f dash d square when replaced by minus 1, in the condition that a must be equal to 0, if it becomes 0, then the particular integral would be x square cosine x divided by f double dash minus. So in any case, what is required? It is required that this term in the denominator should not be 0. That is what is required. It is required that when you are replacing d square by minus 1 in the condition a equal to 0, this entire thing should be non-zero. Because if it is 0, then I will have to resort to these cases, and where I will have where I can see that x is being multiplied with the cosine of x and it will not let it remain periodic. So now understand the term that if this is non-zero, what does it imply? It implies b certainly has to be not equal to 1. So answer would reduce to writing a equal to 0 and b is not equal to. Is that clear or not clear?
भाई लास्ट वाला बता दो ना एकदम
ओके ओके
बस
देखो
वही वाला
मेरी बात सुनने की कोशिश करो. देखो, whenever there was a case of cos ax plus b or sin ax plus b and we wanted to find particular integral, what was the methodology was to replace d square by minus a square. Is that clear? So instead of d square I have to replace by minus a square. If this is zero, if this is non-zero, this term is non-zero, what is the particular integral then? Then the particular integral will be f of minus a square. You write cos ax plus b oblique sin ax plus b. This will be a particular integral. Your job is done. Constant times periodic function will remain periodic. This will be a constant. This is a periodic function. It will remain periodic. But if f when replaced by f when d square is replaced by minus a square becomes 0, then the then the particular integral will be x cos ax plus b oblique sin ax plus b, whatever is the case. I don't know. Right now it is cosine. And then you have to differentiate and then replace instead of d square minus a square. Now, if x is multiplied with any cosine and sine term, it will not let it remain periodic. So this is a non-periodic function. This takes a very long derivation, but overall understand, thoda sa sochoge bhi to it will not let it remain periodic because now your amplitude itself is a non-constant value. Okay, and now, and this is a non-monotonic function as well. So if it all you assume that it is cosine x can become a periodic function for x equal to 2n pi. So you sorry, p equals like period equal to 2n pi. So cos x plus 2n pi will give you cos x, but x plus 2n pi. What about this? Function periodic कब कहलाता है? So if I say that my function fx is equal to cosine x is periodic, what does it imply? Imply if I replace it by x plus 2n pi, it will again come out as f of x. So cos x plus 2n pi would be f of x. But what about this? Where gx is, let's say, x into cosine x. Now what it will become? It will become x plus 2n pi into cosine x. This is fine. X into cosine x is fine, but this term will again come as an addendum. It will never let it remain gx plus 2n pi equal to g of x, or for that matter, any t if you take. So that is something that you can do at home. You can take it as an exercise. It is a long exercise, like it is a calculus standard 11 problem. But overall, understand in any case, whenever your x is multiplied by cosine x or x is multiplied by sin x, it will not let it remain periodic. So what does it boil down to? So here it is. So what I did was I knew that my complementary function will be periodic if a is equal to 0 and b are greater than 0. So we need to keep this thing also in mind. Okay. So I was now I'm finding the particular integral. Particular integral will be cosine x upon f of d. Now instead of d square, replace minus 1. So instead of d square, I replace minus 1 and a is 0. So it will remain b minus 1. Now if this term becomes 0, if this term denominator becomes 0, what does it imply? It implies that instead of replacing like on replacing d square by minus 1, the term has become 0. It implies what? I have to multiply by x and I have to differentiate. This is what I have to do. This is what I was explaining. Okay. But if I do so, then this will not remain periodic. What does it imply? It implies that this denominator cannot be equal to 0. अगर function को periodic होना है, तो this denominator cannot be 0. समझ पा रहे हो? अगर ये डिनोमिनेटर 0 हो गया, दैट इंप्लाइज डी स्क्वायर को जब -1 से रिप्लेस किया था, तब f of d square when replaced by -1 was 0. It implies in order to write particular integral for this case, you have to multiply the numerator by x. And once you multiply it with x, this will not remain periodic. What does it imply? It implies कि for the function to be periodic, ये बोला जा रहा है ना कि सारे रियल सॉल्यूशंस पीरियोडिक होने चाहिए. ये पूछा जा रहा है क्वेश्चन. देखो, all the real solutions are periodic if. तो अगर ऐसा है, so what does it mean? It means that in any case, this should be non-zero. And if this is non-zero, it implies b should be non-equal to 1. So a is equal to 0 and b not equal to 1. Is that clear or not clear? Alpna and Bharat, only two are remaining.
और
Bharat को आया?
Yes, sir. Clear is.
Okay. So I mean, this is it for today. But overall, understand इसको अपन 2 दिन और खींचेंगे बस, इससे ज्यादा नहीं. Then we'll come back to our electrostatics, and probably your question also will solve better. So overall, understand मतलब यही आता है exam में question. One question if you want to take, you can take. But overall, these are the questions which come in the examination. मतलब they want to test your knowledge as well as some presence of mind. But this is a question of presence of mind. If you just try to do this question again, so suppose yp is particular integral is x cosine 2x. If particular integral is x cosine 2x for the differential equation given by y double dash plus alpha y is equal to minus 4 sine 2x, then what will be the value of alpha? Again, gate mathematics. बताओ, फटाफट. Try to solve this question. So it is very much clear that a term x is multiplied. You don't have to get into the like details of this question, or understand that x is multiplied. Is that clear? X is multiplied with cosine 2x. What does it imply? It implies your f of d square when replaced by minus 4 would have been 0. तभी ऐसा कुछ आया होगा. Is that clear or not clear?
Yes, sir.
Okay. It implies what? It implies d square plus alpha when d square is replaced by minus 4 must be equal to 0. That implies your alpha should be equal to what? Khatam. Okay, so these questions are all presence of mind, nothing else. Is that clear or not clear? So tomorrow we are going to do mostly Cauchy-Euler equations, and by a day after we'll be finishing this thing. Is that clear or not clear? यहाँ तक समझ में आ गई बात?
Yes, sir. Clear.
Okay, so we'll be
Alright.
doing, है ना? So we'll be doing 2 more days. Just give me. So 2 दिन तक till these MSc guys are coming, we'll stick to easy things first, and then we'll again shoot the level up. Because otherwise they will not come in the class, and that is a problem. So there will be no such young participation. If these guys are there, at least some questioning will be going on. Otherwise, so समझ में तो आ गया ना आज का जितना भी है.
Yes, sir.
Okay.
हाँ
Okay. 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 ठीक.